All right, welcome back. Today we're going to be doing constructions in geometry, specifically focused on parallel lines. The first construction is going to be parallel lines from congruent corresponding angles. To construct this, we're going to need first a line to which we'll produce parallel. To give yourself a segment, let's pretend it's a line by putting arrows on it. And the first step is to give ourselves a transversal. So we're going to take our straight edge and we're going to give ourselves something that's crossing over our initial line, and it's also crossing over where we're going to have our parallel line eventually. Now, can you visualize that I'm going to have a line about there? That's going to be parallel. And what would be true about the angle right here and the angle over here? They're corresponding angles. So if the corresponding angles are congruent, the lines are parallel, right? So let's see if we can do that. Let's see if we can copy this little angle I'm marking as 1 and put it up here somewhere. So the first thing we need to do is put a little dot on our transversal. It should be about halfway up above this line. I'm going to copy an angle, which we've done before. I'm going to take my compass. I'm going to set it some size so that I can anchor it in my vertex. And I'm going to make an arc that cuts across both sides of the angle, both rays. Doesn't matter the size. But whatever size that is, I'll then pick it up and reproduce it from where I put the dot on my transversal. Those are basically congruent arcs, same radial length, both crossing over this axis. One is hitting our line. Second one isn't quite because we don't know where that line is yet. In copying the angle, once we've got the reference arc created, what we have to do is find out how wide this mouth is. So I'm going to take my compass, anchor it on the point of intersection, and open it until I get a spot that shows me the length across the mouth. And then I'll pick that up and bring it to my copy. Anchor it and make an arc. And what I should find is that if I connect my initial point along my transversal with this point of intersection and I draw straight across, that should give me a line that's parallel to my first line. And the reason it's parallel is because corresponding angles are congruent. Therefore, these lines are parallel. Question? Moving on to the next skill. This is going to be parallel lines from congruent AIA. We know that if we have two lines that are parallel and we look at the alternate interior angles, those are going to be congruent as well. So let's do the same idea here. I'm going to draw an initial line to work with. I'm going to give myself a transversal. And this time, instead of going angle 1 here and angle 2 up here, let's give ourselves a dot that's pretty high on the line. I'm going to put angle 1 here, and I'm going to put my angle 2 over here so that they're in an alternate interior location. But the process is the same. You're still just copying an angle. So step 1 is make an arc. Step 2 is move that arc. Oh, but I don't want it to be here now. I have to move that arc over here, don't I? Yep. I made a reference arc just like we did before. Right? And then instead of picking it up and moving it up to here, corresponding, I'm spinning it around so that I'm creating it in this corner. Now, yours might meet differently than mine. Mine have a little gap here. Yours might fall short of each other. Yours might overlap. That's all fine. Doesn't matter. And then the next step is just as we did previously. I'm going to measure the mouth of my opening here by adjusting my compass so that it just goes through the point of intersection. And then I'll pick that up and do the same thing on my other arc, so that this mouth opening is the same size as this mouth opening. And now by connecting my original point and my point of intersection of the two arcs, I'm going to end up with parallel lines because alternate interior angles are congruent. Good.
Same side interior. Same side.
If we did same side interior, those would be what? Same side are supplementary. We're doing congruent angles, so that doesn't work quite the same way.
Exterior.
Excellent. So the third one is going to be parallel lines from alternate exterior angles. Now, if we think about this as we're doing it, we need to have space for our copied angles to be in alternate exterior locations. So when we put our initial line on, don't put it all the way at the bottom because then we're not going to have room for an angle on this side, right? So put it up a little higher. Give yourself your transversal. And your dot should be kind of down here because we want to have room for, let's see, if we do this angle as angle 1, our angle 2 is going to be up here somewhere. Those are in alternate interior, alternate exterior locations. As we keep doing this, we're going to copy the angle. So start with a reference arc. Then do that same reference arc up here where we want it to go. Measure the width of our reference arc at the mouth. And then carry it up so that our measurement ends up kind of out in space. The mouth is how wide this is. All right. Looking good as I go around the room. Let me finish mine off here. I've got congruent alternate exterior angles. Please be quiet. When the congruent alternate exterior angles are shown with the transversal and up lines that are parallel. And I'll choose a different number of arrows to suggest that these are parallel to each other. These with only one set of arrows are parallel to each other. These with two are parallel to each other. All right, fourth one. We're going to do parallel from perpendicular to perpendicular, my favorite math word. Let's begin with a line. And this time we're not creating a transversal. Do you remember when we did the perpendicular bisectors? Remember more than halfway, the football looking thing? When we did that, we not only got a bisector right through the middle, but we also got a segment that was perpendicular to the first. That's what we want now. We want to make it perpendicular, but let's not go through exactly in the middle. Let's make it somewhere over here. Okay? And what that means is instead of me going from all the way in this end, I'm just going to go from somewhere a little bit closer. I'm going to make a mark of some length, and then I'll come to the other side.
Does it have to reach the end?
It should cross over this line, yes.
No, I mean, does it have to cross like the end point?
No. Once I create this football looking shape, I'm going to stop right after this. Right. So we've made one, right, please. We've made one perpendicular pair. Now we need to make a line parallel to this. So what I'm going to do is I'm going to turn my paper like this, and I'm going to do another perpendicular to here. Same idea. You pick what you want to be the dimensions and what your starting points are. We don't care about this midpoint concept. What we care about is that we get perpendicular. I changed mine to be smaller because it was looking a little crowded in there.
Okay, where we're making it perpendicular to?
Perpendicular to the new line you just made a moment ago.
It's okay if it goes into the football.
Like if the footballs overlap a little bit, sure, that's fine. Now, when I look at these lines, they look a little off to me. I made a little bit of a mistake. I can see my mistake is I didn't hit the tip of my football here. I'm a little bit too high. But for our testing, I'm okay with this, right? We're presenting that we know the process, and the precision is something that we're still working on. If these two lines are perpendicular to each other, then we know that these two lines are parallel. Now, which of our theorems are we using to do this? Jethro?
Numbers of corresponding angles, yeah.
Numbers of corresponding. Okay, if that's the case, then we
They
had,
are corresponding.
we could do this and this. You're right, those would be corresponding. But the ones I've marked, Jahan, all of them, because they're all right angles, right?
Yeah.
And so they all end up being the same. But the ones I've marked, it's a little interesting. What are those? What's the named pair relationship for these? Same side interior. They're not supposed to be congruent. They're supposed to be supplementary, which they are because we chose right angles, which are both congruent and supplementary. So these end up being like same side interiors that are supplementary. Okay. Please flip to side 2. We're going to play a little bit more with perpendicular lines now. We're going to do perpendicular through a point on the line. In other words, let's create our starting line. Put it about in the middle of your section you're working with. Now, we've just demonstrated that while we previously did perpendicular bisectors by going from the end point more than halfway, same from this side, and that produces not only perpendicular, but through the midpoint. How could we do it if we don't want it to be through the midpoint? We want it to be through this point. Casper?
Well, I was thinking maybe you like measure it from that point with the compass and then like measure like the other way and then you know where that dot is.
Nice. Excellent. Can you guys visualize that there exist 2 points here where this point is in the middle? Right? Whatever these 2 points are, I don't know where they are, but somewhere this is the middle of 2 points. There's actually a lot of pairs of 2 points, right? What Casper suggests is let's use this end point here, and we'll go more than halfway, thinking this is our midpoint. And then we have to find the other point here to come back. So before we start this one, what we're going to do, put our needle on the point we're trying to go through, and I'm going to make effectively a whole circle all the way around, but I only really care about going to both sides. This point and this point are equidistant from our center point. So if I use those as my starting points and go more than halfway, it'll be perpendicular through the midpoint of them, but more importantly, through the point we wanted it to be. I'm going to go more than halfway. Come back and do the same thing here.
Wait, what did you do? What do you have to do?
I found these little blue points, which are the points of intersection of a circle around my starting point. And then from each of those, I went more than halfway, the same on the other side. And again, I missed on my bottom a little bit, so my line doesn't quite go through. And this will be perpendicular through a point on the line. All right. Next one. Perpendicular through a point off the line. We've got some segment, and we want to point something like over there. See if you guys can reason out how you would do this to go perpendicular through that point off the line. All right, as I circulate around, I see lots of people figured it out. The trick is we need to find 2 points that are equidistant from this point. So the trick is start with a reference arc again. That gives us 2 points that we know are equidistant. And then from each of those points, I'm going to go more than halfway. And if I connect the endpoints of my football, I will get not only a perpendicular line, but specifically through that point we started on. And mark it as perpendicular. All right. I think you guys have graduated to the challenge now. Well, what can you do now? You can draw parallel lines and perpendicular lines, and you can do them with a lot of your own choice, right? The parallel lines, you draw the transversal, but then you pick where the dot is. That's where the line's going to go, right? And for the perpendicular lines, you can do it through a point on the line, through a point off the line, or a random spot. So would you please utilize those skills to construct a square? You know what a square is, right? 4 right angles, 4 congruent sides. All right. I saw some really good work out there. Let me just wrap up the 2 ways that I saw constructing a square. The first is we begin with something. We say, all right, I want this to be a side of my square. So to find a perpendicular line through a point on the line, we make our reference arcs on both sides. And then from those points, I go more than halfway. More than halfway on the other side, same distance. And what that's going to give me is one perpendicular line. Now, a square has a fixed length. All the sides are the same, and it has right angles. Well, I've given it one right angle. I haven't yet picked the side length. Boom. Now I've picked the side length. That's going to be the side length for one side, and it's got to be the side length for the others. I can do the exact same process I just did. Create a little reference arc here. Same there. And I'm going to go more than halfway. from those points that are equidistant from where I'm trying to go, that will be perpendicular and through that point. This first one wasn't all that critical because I hadn't yet done anything about the other sides. But now I've fixed the side length. This side length has to be repeated. So what I'm going to do is I'm going to figure out how long it is, make a little mark showing that I'm getting it, and I'm going to put it over there. And then I'll do the same thing from here over there. Now, I saw some people just say, okay, well, I've got two angles here, and if I connect these, this side is the same as this side, and this side is the same as those as well. And since these are both right angles, that means this is parallel. And so if I connect those at the same length, it's got to be perpendicular. And you're right. If you wanted to be a little bit more precise, you could do the same activity that we did here and here, making the reference arcs perpendicular like that. I saw someone come up with another interesting way to do it, and I want to just share this. Start with a point in the center and make a circle. Now, all I know is that all these points are equidistant from this point. If I draw a line that goes through the center and touches both edges, what do we call that? Diameter, good. And I now know that these lengths are both the same. If I now come back and from this edge, the end point of the diameter, go more than halfway, and from the other end point of the diameter, go more than halfway, I'm going to produce perpendicular line through the center. Shadows in here a second. Now, do you agree that this length is the same as this length? And this is a right angle. And this length is the same as this length, and this is a right angle. And this length is the same as this length, and this is a right angle. All the way around. Which means if I connect the end points of each of these diameters, this is now a triangle, is it not? It's got a right angle, and it's got two of the sides the same, which makes it isosceles. As we'll learn later, that makes each of these angles 45 degrees. Questions? If you want to do this on the other one, this is optional. My only requirement was that you construct a square. If you found a way to do it, you accomplished the mission. I think this one's a little bit easier. But of course, it assumes knowledge about what a square is. And we'll learn this in the spring when we do quadrilaterals. But it turns out that if you have, these are called diagonals. And if you have diagonals that are perpendicular and equal in length, that will always produce a square. Okay, well done, ladies and gentlemen. You've now done successfully round 2 of constructions in geometry. Your homework tonight is to guess what?
Redo it.
Redo it. Do the exact same things again. Submit that as your homework for the day.